All right, so this is just to do more examples for the tabular method, just so that you have them. So we're going to make the first one u, just like before, and this one dv. But instead of doing integration by parts, we're going to use the tabular method, which is still integration by parts, but we're going to be putting our u here, our dv here. And again, you're always picking just based off our little table that we had in the very first video, but also which one is getting nicer. So simpler. So when we take the derivative of t squared, we end up with 2t and then 2. So doing the derivative twice means we would have to do integration by parts twice on this problem. So the tabular just saves us time. Now the dv is our integral part, right? And it's really that entire thing over here. So you can put dt if you want, but we're just making this nicer. So we integrate. So that would become negative cosine t, and that would become negative sine t. All right, so then we would multiply these together, and then we would do integration by parts again, and we would multiply these together. But that second part right here, this is the previous one we did, that second part already had a minus there, so it changes the signs. So it's this minus the first one, but then if you think about going to the next one, well, that minus is going to change that second minus to a plus, and then so on. So then the next would be minus, and then that minus would change the next one to a plus, and so on. So you get that alternating sign. So we know the first one we're just multiplying, so the second one is minus. There we go. And then the last one would be plus. There's our alternating sign. So this doesn't mean it's going to be minus plus. It just means we've got to make sure we change the sign. So the first one is negative t squared cosine t. And then the next would be a negative and a negative, so that's positive 2t sine t. And then the last one would be these together. And this is our integral. So again, we like to do this. And then I like to put the dt here just so you can see it. You don't have to write that if you don't want to. So it becomes minus because 2 times a negative would be a negative. And that's our last integral. So by doing the tabular, we're taking the t squared, which would mess up our integral and tell us that we have to do integration by parts again. And we just keep doing it and doing it and doing it until we're down to that constant. Now we've gotten rid of the t. We know that at the very end, we're going to be able to integrate this nicely. So this becomes negative 2 cosine t, but we need that to be a plus because the derivative of cosine would be negative. There it is. Remember, you end in a co. You put a negative. We put our plus c. We bring everything down. And there we have it. So just so that we have another one, let's do it again, this time with a trinomial. So again, that would be our u because it will get simpler as we take the derivative. And this will be our dv. Why'd I put x? I'm just used to that, huh? U dv. Yeah. So now we do x to the fifth minus 3x plus 2, and we make it simpler. So you think about it this way. We've got a degree 5. We're going to have to do this until that 5 disappears, so x to the fourth. So that's 1 integration by, that would just be 3. 1 integration by parts. 2 integration by parts. 3, 4, 5. So we would have to do integration by parts 5 times. So it's better just to use tabular method. All right, so this is e to the negative x, which would give us negative e to the negative x, which would give us e to the negative x, which is negative e to the negative x, which is e to the negative x, or negative e to the negative x. We just fill in our integral. So this is integrating, right? So it would have been so e to the negative x, right? The derivative of that would be e to the negative x times negative 1. So we need the negative to cancel it. And there you have it. Now, the first one is always positive, and then these two will be negative, positive, negative, positive. And then the last one is also negative. So it's going to be a minus like it normally would when you do integration by parts. All right, so the first one is negative. Let's zoom in a bit so I can have some room here. It's going to be a lot. So the first one is negative x squared minus 3x plus 2 e to the negative x. And you can distribute that negative if you want. It's not squared, it's fifth. There. And then the next one would be also minus. So we get 5x to the fourth minus 3 e to the x. And then the next one would also be minus. So we're not getting an alternating on this one. And the next one would also be minus. And then we would get minus. And then we end up with the integral at the end, which is also a plus actually here because it's a negative negative. So plus integral. Where did I get 125? 120. There we go. 120 e to the negative x dx. But when we integrate it, it becomes a negative. So, all right. So now if you look at all of these, they all have a negative e to the negative x. So that's what we're going to factor out. And then now we can write x to the fifth minus 3x plus 2 minus 5, plus 5x to the fourth minus 3 plus 20x cubed plus 60x squared plus 120x. It's good to check these. They should be descending. And then plus 120. So I factored out the negative so we didn't have to deal with it. But you could also have left the negative in as well. All right, like terms now. So we have x to the fifth. You just put parentheses here. X to the fifth. And we will put a little check mark there. Okay, who's next? That's x to the fourth. And so that one. And we'll put a little check mark. And then x cubed. A little check mark. And then now onto the x squared right there. 60x squared. Didn't give me the red. There we go. And then now we move on to the x's. So we have a 3x. Now we still have that 2 and that 3, the 2 and the 3 right there to add together. And then that's a 120x. See, we missed these things. Okay, so that 3x and the 120x actually go together. I knew I had too many there. You shouldn't have like terms like that right next to each other. All right, so 120x and 3x is 117. All right, now back to the 2. So the 2 and the 3 makes -1, plus the 20 is 119. And there we go. Now we forgot one little tiny thing, plus c. Did I put a plus c on up there? Yep, I did. All right, so when you see problems like these, it's just basically nth degree polynomials will work very nicely with it. When you see that, just use the tabular method to decrease these values. And there you go.